Today we're going to discuss an essential part of building a Nano movie recommend system. Design a data structure use JSON. We'll go step by step to understand what JSON is, why it's useful, what kind of data we need, how to store it in JSON, and how our system will use this data to recommend movies. By the end of this class, you will have a clear understanding of how to structure and organize data for our recommender system. Why JSON? Before we dive into designing our data structure, let's first understand why JSON. JSON is such a popular choice for storing and exchanging structured data. JSON has several key advantages. It's human-readable, meaning it is easy to understand. It's lightweight, using minimal formatting, making it efficient. It's cross-platform compatible, supported by almost all modern programming languages. It has flexible structure, allowing us to store complex data like lists. As you can see, JSON is a great choice for handling data in applications like movie recommend system, which needs to store and process structured information efficiently. What is JSON? Now let's take a close look at JSON itself. JSON data is stored as key value pairs. Each key represents an attribute, and the value holds the actual data. For example, here's a JSON object representing a movie. As you can see here, the object stores the movie ID, title, genre, release year, and rating, all structured in a way that both humans and machines can understand. To build a recommendation system, we first need to determine what information is necessary. Basic movie information. Each movie should have a movie ID, a unique number for each movie, a title, the name of the movie, one or more genres, such as romance, a release year, indicating when the movie was released, a rating, representing how well the movie is received. For example, some of the movies in our data include Interception, The Matrix, Titanic. And for the future use, we also need the user preference. To personalize recommendations, we also need to store user data. The user ID, a unique identifier for each user, a list of watched movies, indicating what they have already seen, their liked genres, so we can match recommendations to their taste. The rating given, which are the scores they've assigned to movies they've watched. For example, user 101 has watched Inception and The Matrix and rated them 9 and 8.5. As you can see, we need both movie data and user preferences to generate accurate recommendations. How to convert this data into JSON? Now that we've structured our data, let's convert it into JSON format. As you can see here, each movie is stored as an object inside an array, making it easy to access and process multiple movies. About the user, here as you can see, we are storing a list of watched movies using their movie IDs, a list of liked genres to match recommendations, a dictionary of ratings where the key is the movie ID and the value is the rating given by the user. This structure ensures that we can easily retrieve and analyze user preference. How the system will use this data. Now that we have our JSON data, let's briefly go over how our system will process it to generate recommendations. First one, user input. The user selects genres they like or rate a few movies. Filtering. The system finds movies that match users' preference. Sorting and rating. The system ranks movies based on ratings and similarly to the user's taste. Output. The recommended movies are displayed to the user. As you can see, structuring the data properly allows us to build an intelligent recommender system. What's next? Now that we have our data, model, and JSON format, the next step is to store and retrieve the data efficiently using Python. In our next lesson, we'll write Python code to store movie and user data in JSON fields, load and update the data dynamically. Use this data to generate recommendations based on our user preference. Thank you for listening. I'll look forward to our next session where we'll bring this data to life with Python. See you next time.